And again, it's one numerator and it's one denominator. Okay, and it could be any numerator. It could be this way. We could see that, oh, this fraction can be simplified. In this case, it can't, but it can be this way too. So if I look at the 8 and the 16, I can see that 8 and 16 are both divisible by 8. So I can go ahead and I can divide them both by 8. 8 divided by 8 is 1. 16 divided by 8 is 2. And then I look on this diagonal, 9 and 15, and I can say, oh, you know what? They're both divisible by 3. And 9 divided by 3 is 3. And 15 divided by 3 is 5. And then I don't have any, between either numerators or denominators, any more numbers that I can divide by. So then I can do my multiplication, numerator times numerator over denominator times denominator. So my 1 times 3 is 3, and my 5 times 2 equals 10. And I get 3/10. If I didn't do that, if I just multiplied straight across, back here, 8/15 times 9/16, I'd get 72 over 15 times 16. I get to do that over here. That's 80, and that's 160 over 240. Okay. All right. And then here I would do some simplifying. I'd say, oh, I know they can both be divided by 2. And divide them both by 2, and I get 36 over 120. I see 36 over 120, and I say, oh, those both can be divided by 2. And I get 18 over 60. And I said, oh, those both can be divided by 2. And I get 9 over 30. And I take my 9/30ths, and I say, oh, those both can be divided by 3. And I get 3 over 10. Okay. There's my final answer after 1, 2, 3, 4 times simplifying it, as opposed to my 3/10 after 1 time simplifying in my cross canceling or cross simplifying. So we look for a common factor between the numerator and the denominator before we multiply. It makes the math easier. There's less to simplify, and it makes multiplication. I had to do 8 times, 15 times 16 over here to get my 240, when here my denominator times denominator was just 5 times 2. Okay, so we're going to do a couple more examples.